Hi, everyone. For our first topic, I want to introduce the concept of numbers, or more specifically, I want to introduce the topic of integers. Now, this may seem fairly easy to some of you, and if that's the case, don't be afraid. These will get slightly more difficult as we go, more challenging, and therefore more exciting, hopefully. But we're going to start off pretty simple, and we're going to kind of ease our way into more challenging topics as the semester goes on. Okay? So the simplest way we can think of an integer is just a counting number, whether it be positive or negative, and the number zero. Okay. So when I say a counting number, I mean one, two, three, four, five, so on, off into infinity. Okay. Every positive counting number. And I also mean negative one, negative two, negative three, negative four, so on, all the way off to negative infinity. And we're also going to include the number zero. Okay. And we can express the set of integers just how we have it written here. Okay, you have a set of three dots on the left. That indicates it goes off to infinity to the left. The pattern continues to infinity to the left. Then we have negative 3, negative 2, negative 1, 0. Then 1, 2, 3. And then we have three dots on the right. And that indicates that it goes off to infinity on the right. Okay, so this is one way of writing the set of integers. All right. So I want to go through a few examples and just see whether or not these numbers are indeed integers. Okay. So we'll check yes if it's an integer, and we'll check no if it's not an integer. Okay. So this first one here is the number 12. Now 12 is a counting number, so automatically it would be an integer, right? So we could count up to it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's on this list of numbers we have listed up here immediately and obviously. Okay, let's take a look at this next one though. How about 18 over 3? Now, at first appearance, this may not seem to be an integer because it's written as a fraction. You don't really see that anywhere on the number line. But we can rewrite 18 over 3 as just the number 6. Okay, and to see this, we can just divide 18 by 3. 18 divided by 3 is 6, and to go backwards, we can multiply 6 by 3 to give us 18. Okay, so since we can write 18 over 3 as a whole number, specifically here the number 6, we would say that this is an integer. Okay, and how about negative 78? Now, this is a counting number. It's a negative counting number. However, it's pretty far off to the left here, so I'm not going to count to it to demonstrate that. But you could look at a number line and see that negative 78 is indeed a whole number on the number line. It's just negative. Okay, so we would again say that this is an integer. Now, the number negative 49.39, that is not a counting number. It's negative, but it is not a counting number. Okay, so we're not going to be able to count to it whether we're going to the left or to the right, and there's no way to rewrite it in that way like we did with 18 over 3. So we're actually going to say that no, this is not an integer. Okay, now let's look at negative 16 over 5. Now, you may be tempted to try and simplify negative 16 over 5 like we did 18 over 3, and in reality, that's a good strategy to do to see if you can simplify it. But the one thing we're looking for is that we can cleanly divide 16 by the number in the denominator. So the only number that we're going to get, in this case, it's specifically 16, but the only number we're going to get an integer is if we can cleanly divide the numerator by the number in the denominator. Okay, and the numerator is the number on top, the denominator is the number on bottom. Okay, so if we can cleanly divide what's on top by what's on bottom, then we are able to say that that is an integer. However, 16 is not divided cleanly by 5. So we're going to say that no, negative 16 over 5 is not an integer.